it says, let's see, what is the probability that two or less people are left-handed? In this case, X is equal to 0, 1, and 2. So in this case scenario, you want to do binomial CDF because you want the probability of 2, but everything below 2. So that's how you know to use either PDF or CDF. PDF, if you want to find the probability of a singular event or a singular X occurring. Pretty much for CDF, if you want to find the probability of that event occurring and everything below it all the way down to 0. So on your TI-84, for this one you do binomial PDF. You do n is 10, p is 0.12, x is equal to 2. For B, you'll do binomial CDF. You do 10, you do 0.12, and you also use the highest x value that you have. Okay, you have to tell it which value are we going to start from and go all the way down to 0. So yeah, so that's the difference between binomial PDF. PDF, if you want to find just a singular x value. CDF, if you want to find that probability of that x value, but also everything below all the way down to 0. Any follow-up question in regard to binomial PDF versus CDF?
Thanks.
Yeah, no problem.
But I mean, did I forget anything else, or was that the only thing that I missed?
I think that was the only thing that you missed.
Okay. I like to be thorough, so.
Yeah, I know. All right. Any other question in regard to any of the topic that I posted on Canvas?
One thing that I would like to go over, if that's okay, is the correlation coefficient. How, just to go over that problem one more time.
Yeah.
That's something, yeah. Go ahead.
Sweet. All right, so we'll do correlation coefficient.
Yeah, I think specifically, like, I just want to remember how to calculate it properly, because or to input everything and calculate it when it comes to putting all the data into the formula.
Okay, yeah, sound perfect. Let me do. So let's do this. All right. So say we're trying to find R. So we want to find R, and we're given pretty much two data sets for X and Y. So one thing that you should kind of know, you just want to use a calculator. Like for this one, like you don't want to do it by hand. Like just do it straight up with the calculator, because that way it will be super easy. So X should always go into L1, Y should always go into L2. So what I'm going to go ahead and do, I'm going to go ahead and transition over to my TI-84. So you want to enter X into L1, Y into L2. So we go to stats, you go to edit, and you go to clear and edit. Right. So we want to put 2, 5, 7, 10, and 12. And then for L2, we do 20, we do 18, you go 10, you go 7, and you go 1. So like once you enter the data, I kind of recommend you to kind of look it over. That way you can kind of make sure that you didn't enter anything incorrect. So you kind of give it like a little pass over and look it over. For that way you know that like your L1 and your L2, everything should be fine. So once you do L1 and L2, all you have to go ahead and do, hit the stats button again. You go right here where it says calculate, and we do the linreg AX plus B. Cool. All right. So if you look at X list, it says L1. If you look at Y list, it says L2. Frequency list, that should be left clear. Store required equation, that should be left clear. So I'll just go to calculate and just go right here. All right. So if you look at my R value, R is equal to negative 0.9735. All right. And that's how you find the R value. So it shouldn't be that bad. Like the hardest part will you be entering the data set into your calculator. But when you're entering the data set into your calculator, you just be careful entering so that way you don't get any any wrong value into your L1 or L2 list. But any question in regard to how to find R?
No, but on page 7, there's also the where we have to find x times y, x squared, and y squared as well, and that is really trying to find like the strength of that. The difference with that formula is trying to find the strength instead of just trying to find r. Right? Is that?
Here, let me pull up the study guide.
But well, I guess we could tell the strength from both of them. Let me see.
Are you talking about the least square regression line?
Oh, it's on page 7 in the. Let me see.
Oh, page 7 in chapter 4?
Yeah, it says find the correlation coefficient and comment on the strength of the correlation coefficient.
Let me see my annotated. There we go. Are you talking about this page, Anthony?
I'm talking about the one below on page 7. That the formula, that one right there.
Yeah, it pretty much, you have to just use this table that I gave right here.
All right.
So
Nice.
say like for us, we got negative 0.9735. So if you look right here on this one, if you look how it says absolute value of R, so that means if I have a negative, that means you say convert it into a positive value. So instead of me using negative 0.9735, we're gonna do the absolute value of negative 0.9735, which is just positive 0.9735. So if you look at positive 0.9735, it falls under here. So it falls under this one. So we would say it has a strong correlation because it's between 0.7 all the way to 1.
I guess the last thing I'll ask is what's the difference from just doing finding x and y rather than using x times y and x squared and y squared in that big formula?
Well, the only thing different is this one you're doing it by hand
I see. All right.
and just using the calculator. But for the test, you just want to do it with your calculator, just because you're not gonna have enough time to do like everything by hand. So you are gonna have to like rely on your calculator for this test. So just use the calculator, make sure that you enter the value, and just make sure the value you enter are correct. And then you just enter it into the calculator, and the calculator will give you pretty much everything you want.
Yeah, thank you. Appreciate it.
No problem. All right, so if we go back to the calculator and see what value does the calculator give us, let me turn it on. So if you look at it, it gave us R value, but if you look right here where it says y equal ax plus b, it gave us this equation. So it gave us y is equal to ax plus b, and it tells us a is equal to negative 1.93, and it gave us b, which is 25.1. So let me transition over to my notes. So this is what the calculator gave us. When the calculator gave us this, they gave us the linear model or the least square regression line. Because all you have to do is just substitute this in and you get y hat is equal to negative 1.93 x plus 25.1. So if you look at the calculator gives you the R value, but it also gives you the least square regression line. So that's like the hardest two things to find. So you do want to rely on the calculator to find you the R value, but also to be able to find you the least square regression line or just the linear model. All right, but that's it for chapter 4 in regard to that part. Any other question in regard to chapter 4 or any question about other chapter?
So what's on the quiz today?
Surprise.
All right,
You'll find out once you get there. It should be an easy quiz. All right. Any further question about a study topic on the final?
Can I go again?
Yeah, go for it.
I want to see if we could get a quick refresher on the general addition rule and probability, specifically the page 14.
Which one was that again, Anthony?
It's the general addition rule, and it's a question about Warner Brothers.
Okay, sweet. Warner Brother, Warner Brother. Which chapter was that one again?
Chapter 5.
All right. So here is the problem for Warner Brother, and this is the general addition rule. So the general addition rule is saying probability of A or B is equal to probability of A plus the probability of B minus probability of A and not C of B. All right. So the general addition rule is saying you have to kind of be careful about the overlap. So for the overlap, you kind of really have to take care of it because you can't count the overlap because you count the overlap, you're essentially counting it double versus essentially only counting it once. So in this probably kind of total that 20% of movie coming out of Hollywood are comedy. So we put probability that this event is comedy is equal to 20%, but we're gonna put 0.20. Then if you look at it, it says Warner Brothers have been the lead studio for about 9% of recent movies. So we'll put Warner Brothers is 0.09. So that's the other thing you kind of want to be careful on, turning percentage into decimal. Because for some of you, you have trouble turning percentage into decimal. So just like the easy way to do it, always just divide it by 100. If you have trouble turning a percentage into decimal, because some of you might put 0.9 versus putting 0.09, and that will be completely wrong. And then lastly, if you look at it, it says 2% of recent movie are comedy from Warner Brother. So that's telling me, oops, sorry about that. I think I'm up. So that's telling me the probability we have a comedy and it's from Warner Brother is equal to 0.02. Any questions so far for anything input for A? So the reason I know I had to use the general addition rule is because if you look right here, it says or. So the general addition rule, you're always going to use it when it says or. So if I say find the probability of this or that occurring, you want to use the general addition rule. So for the general addition rule, all you have to do, because what we want to do, we want to find the probability is comedy or from Warner Brother. So you have to do the probability of comedy, which is 0.20, plus the probability from Warner Brother, which is 0.09, subtracted by the probability is from Warner Brother and comedy. So if you do that, you should get 0.27. And that's it for that one. Any question for the last problem?
No, thank you though.
Yeah.
Especially in the call out for the percentage, the decimals.
Yeah.
Yeah, that's me.
Well, I didn't want you to out yourself, but yeah, like if you do know you have that problem, you just divide by 100. If you divide by 100, it will always give you the correct thing. Also, you might want to also practice this with the two-way table. Just say, let's see. All right. So say we're doing this problem where we want to find the probability that someone has a iPhone or is over 30. So you kind of want to just use the two-way table in your advantage. So you want to find that they have an iPhone or that they're over 30. All right. So what you could do, you could either get the total of those amounts. So if you look at how many people or total people we have that have iPhone, we have 60. If you look at how many people do we have that are over 30, you have 70. So what we could do, we could find the probability. So I'm gonna denote this as A. I'm gonna denote this as I. So we want to find the probability they're over 30 and, well, sorry, or have an iPhone. So you want to find the probability they're over 40, over 30, sorry, plus the probability they have an iPhone, subtracted by the probability that they are over 30 and have an iPhone. So if you look at this one, you can see like how many people do we have that are over 30? So you have 70. And you want to divide that by the total. In a little bit, we'll find the total. Then what you want to do, you want to add it to how many people have an iPhone. So if you look at that, that's 60 out of the total. And then what you want to do, you want to subtract it by how many total people do we have that have iPhone and are over 30. So that's this over here. So that's 20. And you divide this by the total. Right now, let me find the total. So if you look at how many people do we have that are under 30, is actually 90. So if you do 90 plus 70, you get 160. So all you have to do is do 70 divided by 160 plus 60 divided by 160 minus 20 divided by 160. And if you look at that, you get 68.75%. And that's how you want to deal with a two-way table. So you should know how to find the general addition rule, either by using the two-way table or if I just give you the actual percentage. But that's it for that one. Any question or follow-up question in regard to this problem?
I just want to say thank you. That helped a lot.
Yeah, good. All right. Any other questions? Any other question in regard to anything on the study guide? So everybody prepare for this final, I see. Page 14, chapter 4, page 14, chapter. All right then. All right, so let's go to page 14, chapter 4. Got that. All right, so pretty much this one is the residual. So you just remember the residual? You want to use this formula as E is equal to Y minus Y half. Okay. So that's the formula that we're going to use for the residual. All right. So if you look at this question, it says consider the Kia price data. Calculate the least square regression line for the price of a Kia. All right, so that's the first thing we want to do. We want to find the least square regression line for this data set. So here's my data. We'll put data right here. Cool. And if you look at it, we have mile and the price of the car. So we kind of have to figure out which one's our X variable, which one is our Y variable. So the X variable is the independent variable, and the Y variable is the dependent variable. So the Y variable depends on the X value. So if you kind of look at this, the price of the car kind of depends on how many miles does it have. The more miles that it has, well, the less it should cost. The pretty much the more mile, or sorry, the less mile it has, the more it should cost. So for this one, we're gonna say mile is X. We're gonna say price is Y. So that means this goes in L2, this goes in L1. All right. So I'm going to go ahead and enter this into X. Well, L1, I'm going to enter this into L2. So I'm going to go to the calculator. Let me show you to go to the calculator. Right. So we're going to go to stats. Oops. First, turn it on. Go to stats. We're going to go to edit. And if you look at this, I'm going to clear this. So to clear it, I'm going to just highlight the top row. And you press clear, enter. Same thing with L1. I'm gonna go press up, press clear, and press enter. So for L1, you put 9,300, 10,565, 15,000, 15,000, 17,764, 57,000, 65,940, 73, 676 77 006 93 79. Three, two, six. All right, so that's my L1. Then I'm gonna go to L2. It is 7100. 15 5 0 0 1 4 0 0 4 4 0. All right, so you enter all of the data set in. Once you enter all of the data set in, you go to stats, you go to calculate, you go to number 4 where it says ln reg ax plus b. You put x as L1, you put y as L2, and you go ahead and it says calculate. So if you look at R, you get y half is equal to a, which is negative 0.05, x plus b, which b is 8136.15. All right, so that's the least square regression line. Any question on how we got the least square regression line of negative 0.05 x plus 8,136 with 15 cents? All right, so let's move on. All right. So if you look in the bottom, it says we're finding the residual. So it said, what is the residual for a car that has 57,000 miles? So if you look at this, we want to find the residual for car number 6. So we kind of want to see how far off is our predicted value from the actual value, because that's pretty much what a residual is. It's telling you how far off, or essentially telling you like what is the leftover. So what we had to do, we had to find out how far off was our prediction from the actual price of a car that has 57,000 miles. So up next, what we had to go ahead and do, we're going to have to go ahead and find y hat. So in order to find y hat, we're going to say y hat is equal to negative 0.05 times x, and x is the 57,000 miles. There you go, 57,000 miles plus the 81,000 or 8136 with 15 cents. So I'm actually going to go ahead and calculate that on my calculator real fast. So I'll do negative 0.05 multiplied by 57,000 added to 8136.15. All right, so you get 5286 with 15 cents. So we get y hat is equal to 5,286 with 15 cents. So instead of putting y hat, we're going to put 5,286 with 15 cents. So that's how you find your y hat. So in order to find y is the corresponding value that corresponds to that x, which is the 4,600. So right here, we'll put 4,600, and we'll subtract the 2. And that would give us our residual. So if you do 4,600 minus 52.86 with 15 cents, you get the residual equal to negative 686 with 15 cents. And that's how you want to do the residual. So for the residual, you first want to find what y hat is equal to. Once you find what y hat is equal to, then you want to go ahead and start doing the subtraction of y hat from the actual value. And the actual value should always be in the table set. Any follow-up question in regard to this last problem? So, all right. Any other question you want me to go over? Yeah, you're welcome.
When we do the final, is it going to be in order from chapter 2 to chapter 10, or is it going to be like randomly placed?
It's not going to be in order because the thing is, like if I put them in order, it's essentially going to go from like the easiest to the hardest. Because then you're going to have like a bunch of problems from chapter 9 and chapter 10, which those are a little bit more lengthy. So I do kind of mix them around where I put like 2 easy questions, then I put like a harder question. So that way you're not kind of like freaking out thinking that like all the hard questions at the end, they're kind of like sporadically all over the place. So that way it will make it easier on you where you don't have to worry that all of the hard questions are all the way at the end.
And then regarding the final, you said you're going to be on Zoom the whole time for questions. So we'll just, if we have a question, we just log in and either submit it in chat or per video.
Yeah, exactly. So you just go to Zoom pretty much how you went to Zoom today. And then you can just ask me any question for like clarification or anything like that. All right. So the final, once you log in, it's 2 hours.
I checked this morning on the final and it says it's worth 101 points. Is that the new total for the amount the final's worth?
No, I'm gonna adjust this. So pretty much I'm gonna double up everything. So at the end, it should be worth 200 points.
All right, thank you.
Yeah, because it should be worth 200 points. I still haven't adjusted it. I first wanted to do out of 100. Then once I do out of 100, I'm gonna double up all of the points. Yeah, there's not gonna be any uploading work. It's pretty much there's gonna be multiple choice, fill in the blank, or there's also some essay question. But the essay question is essentially it's like conclusion. So just seeing if you know how to do a conclusion. Any other question in regard to the study guide?
Can we kind of review confidence intervals in chapter 9 a little bit?
Yeah. Is there a particular confidence interval for P or for mu or both of them?
Just both really quickly.
Okay, sweet. All right, let me upload those notes. All right, so let's do All right. So this is how you find the confidence interval for what you call it. This is how you find the confidence interval for the population proportion. So you want to find your critical value, which is z alpha divided by 2. You want to be able to find margin of error, which is z alpha divided by 2 multiplied by p hat times 1 minus p hat all divided by n. And don't forget the point of estimate. The way that you find the point of estimate is p hat is equal to x divided by n. Once you get the point of estimate and once you get E, which is your margin of error, you just do point of estimate plus or minus the margin of error. So let's go ahead and do this. So let's do a problem. So for this one, it says in July of 2018, a university poll asked 1,783 registered voter nationwide whether they favor or oppose the death penalty for a person convicted of murder. 1,123 were in favor, attained a 90% confidence interval for the proportion of registered voters nationwide who are in favor of the death penalty for a person convicted of murder. So first thing you kind of want to look at everything that's given to you. So the first thing that's given to you, the 1,783, but that's just your n. So n is equal to 1,783. And then they tell you that of the 1,783, 1,123 are in favor. So we'll say X is 1,123. They also tell you that you want to find a 90% confidence interval. And if you look right here, it's for the proportion. So we're saying 90% confidence interval for the proportion. All right. Everybody good so far with that? All right. So for the 90% confidence interval for the proportion, that just we're going to use that in order to get our z value. So to get our z value, if you remember, I gave you, well, I didn't give you, but I uploaded the t table. So we want to get the t table right now. So we want to look for 90%. So if you look right here, it says confidence level. Right here it says 90%. So you get 1.645. So we get 1.645. So you get
And,
one.
and that number, the 1.645, that's the critical value, right?
Correct. This is the Z alpha divided by 2. All right. So we found our critical value. If you go to step number, well, not step, but if you go to part C, it says find the point of estimate. So the point of estimate is P hat, which is equal to 1,123, all divided by 1,783. So I'm gonna go ahead and do this calculation. So you get 0.6298. So if I do 1,123 divided by 1,783, you get 0.6298. Everybody go with that so far? All right, next we're gonna do margin of error. Margin of error. So for margin of error, we're gonna get the Z value, which is 1.645. And we're gonna multiply that by P hat, which is 0.6298. And we're gonna multiply that by 1 minus 0.6298. And you divide all of this by the total amount of sample size, so your N value, which is 1,783. So I'm gonna go ahead and do that real quick. So if you go ahead and calculate this, if you round it out to 4 decimal places, you get 0.0188. So that's your margin of error. So that's how much we're gonna be off by, or we can be off by from the point of estimate. Because we kind of know the point of estimate is not gonna be the correct answer, but the margin of error telling us the point of estimate doesn't have to be exactly correct, because the margin of error telling us how much wiggle room do we have. All right, and then lastly, to find the confidence interval, we get the point of estimate, and we add and subtract it from our margin of error. So let me go ahead and do that. And that will be our final answer for that problem. Any question in regard to this one so far? All right. So also, if you remember, just a way to do this in the TI-84. So I'm gonna go ahead and transition over to the TI-84. For that, I can show you how to do it with the TI-84. So for the TI-84, you wanna go right here where it says stats. You wanna go where it says tests. And you wanna go where it says one prob Z test. Oh, sorry, we want one prob Z interval. Because one prob Z test is chapter 10. So we go right here where it says one prob Z interval. So if you look at X, X we said was 1,123, N was 1,783. C level, which is confidence level, is 90%. You go calculate.
In the calculator, do you put it as a the confidence level as the whole number or a decimal number?
For my experience, it doesn't really matter. If you put it at 90 or if you put 0.90, it should actually give you the same thing. But if I were you, just kind of double check that with your calculator, because I know for like the TI-84 and the TI Inspire, it does, like, it doesn't really matter if you put it as a whole number or as a decimal. but you try test it out with your calculator. You put it as a decimal, put it as a whole number, and see, and you see does it give you the same thing. It should give you the same thing, but you double check it just to kind of make sure. All right, but that's how you do the confidence interval for a proportional data set. All right. Any question in regard to the last prompt? All right, so let me go back to my screen. All right, so let me give you some pointers. Like if for the test, well, for the final, if I give you something that looks like this, where I kind of break it down by step, you kind of want to do this by hand because like the calculator doesn't really give you the margin of error or it doesn't give you the critical value. So if I do give you something that is asking you find the critical value, find the point of estimate, find the margin of error, this is something that you want to do by hand. But say if it only say construct the 90% confidence interval, if it says that, pretty much all you want to go ahead and do, you do it with the TI-84 or whichever calculator you have. So you kind of look at the problem, gauge it. If it's asking for margin of error, if it's asking for the point of estimate, you might want to do it by hand. But it's a question just asking, find this confidence interval. Just do it with the calculator, so that way you can do it way quicker. All right, but any question in regard to this before we move on to the confidence interval for the mean? All right, so let's do confidence interval for the mean. Okay, so let's do this one. So for this one said the following data represent the age in week at which a baby first crawled based on a survey of 12 mothers conducted by Essential Baby. So for this one we have 52 week, 30 week, 44 weeks, so on and so forth. So for part A is to use the information from the sample to get the best point of estimate of the population parameter. So for this one, the population parameter is pretty much how many weeks does it take for a baby to first crawl. So since we want to figure out the weeks of which the baby first crawl, the best point of estimate will be X bar. So in order to find X bar, you're gonna have to enter this into L1. So let me enter this into L1. So I'm gonna transition over to my TI calculator. So we'll go to stats, we'll go to edit. Let me clear this list. Clear this list. And let me enter the data set. So we get 52, we get 30, we get 44, oops, put a 4 to the 44. 44, 35, 47. All right, so let me look over the numbers again just to make sure all of these numbers are correct. So 52, 30, 44, 35, 47, 37, 56, 26, 39, 26, 39. 28. All right. So you enter the data set to L1. If I want to find the mean, but also if you look at the question, it also wants you to find the sample standard deviation. I want to go to where it says stats. You want to go calculate, and you want to do 1 bar stats. So you do 1 bar stats. You say L1 is your data set. Go ahead and calculate. All right, so if you look at the very first thing they gave me X bar, which is 38.25. If you look at it, 4 below, if you look at it, give me S of X. X of S is standard deviation. So they're telling me standard deviation or sample standard deviation is 10. And you kind of know this is a sample because they only gave me 12 babies. They didn't give me the entire population of babies. So that's why we're using S of X, not sigma of X. All right. But any questions so far with this calculation of sample mean or sample standard deviation? All right, so let me go over and transition back to the notes so that way you could see that I entered that for the sample mean and that for the sample standard deviation. All right. So we have the sample mean, which is 38.25. We have sample standard deviation, which is 10. So for part C, it says constructing 95% confidence interval estimate for the mean age at which a baby first crawled. So we want to do 95%. So if you remember for the mean, where we're doing the population for the mean, or we're trying to find the parameter for the mean, what we want to do for this one, we use the t-test. Well, sorry, the t-distribution. So we're using the t-distribution. So when we're finding the critical value, instead of finding z alpha divided by 2, you're actually finding t alpha divided by 2. So the way that you find t alpha divided by 2, you need 2 things. You're going to need your confidence level. So we'll put confidence level is equal to 95%. But you also need degrees of freedom, where degrees of freedom is n minus 1. So that'll be 12 minus 1, which is 11. All right. Any question for confidence level or degrees of freedom? All right, so I'm gonna go back and I'm gonna go to my T table. So the T table, I'm looking for confidence level 95%, degrees of freedom of 11. Right. So if you look right here, here's DL. So degrees of freedom of 11 is right over here. Now, if I go down here for confidence level should be right over here. So if you look at where do they intercept, they intercept at 2.201. Any question on where the 2.201 come from? All right. All right. So let's go ahead and do this. So if I want to find the margin of error is equal to 2.201 multiplied by 10, so that's your standard deviation, divided by square root of n. Square root of n, well, n is 12. So let me go ahead and do that right now. So you go 2.201 multiplied by 10 divided by square root of 12. So you get 6.35. So if you look at my mean, it's 38.25. So you do 38.25 plus or minus 6.35. So if we do 38.25 minus 6.35, you get 31.9. Now, if you add them, you get 44.6. And that's how you do it if you're doing it by hand. But also remember, you could always double check your answer by just using the TI-84. So if we double check our answer using the TI-84, we could go to stats. Well, you go to stats, you go to test, and you want to do the T interval. So the T interval, and remember, you enter the data set into data. So make sure you say data, and then you put L1, and you change your confidence level to 0.95. All right. And if you look at it, you get almost exactly what we got by hand. So that way you kind of make sure that you're on the right track. So you get 31.89, which we just rounded up to 31.9. And you get 44.6, which we got. All right. But that's it for that last prompt. Any question in regard to this last prompt?
So for the T interval, you have to put it as a decimal, or does it not matter again?
No, it doesn't matter. We just kind of showing you it doesn't really matter because the last one I put it as a percent or a whole number, and this one I put as a decimal, so it doesn't really matter. Because I could go back, go to stats, go to test, go to a T interval, and we could change this to, oops, went a little bit too down. We could change it to 95%, and you get the same answer. But if I were you, just kind of double check that with your calculator. So just do it as a percent and then do it as a decimal. You should still get the same answer, but you kind of just do it beforehand for that way you know it doesn't really matter how you enter it into your calculator. All right, any other questions? So that was the example for confidence interval for proportional data set, but also confidence interval for the mean. Any other question in regard to this study guide? All right, so if there's no any further question, what I'm gonna do, I'm gonna shut down this meeting and I'm gonna go to my office hours. So if you do have any questions about anything, about your grades, about pretty much any other topic, you can just stop by into my office hours. So just remember the final exam is gonna be on Wednesday. So it's gonna open up at 10 a.m. and gonna close at 2 p.m. So whenever you have time, a 2 hour gap in between, you want to take that test. So the latest that you could start it is at 12 p.m. Because remember, it's gonna close at 2 p.m. So if you start off at 1 o'clock, you only have 1 hour to do that. So make sure that you actually start either at 12 or somewhere before 12 so that we could get the full 2 hour for this final. All right, so this is pretty much it for this semester. There's not going to be any lectures anymore after this. If you do have any question, you can email me through Canvas. If it's something that you kind of have to ask me through the Zoom, you can just ask me if I have time anywhere tomorrow. And pretty much tomorrow, my calendar is free all day. So if you have a question that you kind of want me to explain, just let me know what time you want to meet up with, and I'm pretty sure I can accommodate that time. But just email me beforehand. Don't email me like 5 minutes beforehand and expect me to be there. So just kind of give me a good enough notice. All right. Thank you for taking my class. Unfortunately, it ended up as an online class, but hopefully that didn't hurt you that much. All right. So that's it for the semester. And if you have any questions, email me. Have a great, well, great rest of the day.